What is custard? Custard is a culinary preparation made by blending eggs with milk or cream, and it is thickened by the coagulation of the egg proteins, which is achieved by gently heating the custard in some way. Usually, the texture is creamy and velvety, and often colored with a blend of tartazine yellow and exhibited non-Newtonian behavior and structural viscosity. Traditional custard versus instant custard. For traditional custard, it must have double cream, whole milk, egg yolks, corn flour, custard sugar, vanilla extract added into it, and it is cooked in a pan and need constantly stirred. Usually, it will take about 15 to 30 minutes to cook it. While for instant custard, it is a powder to make a custard sauce from simply by adding water, and it is cooked in a microwave and no extra work needed, and usually it will only take 3 to 5 minutes to cook it.
Okay, so the most important thing that we need to know about the instant custard is the ingredients. So the main ingredients in the instant custard is the starch. So how the starch functions to thicken the instant custard? Okay, first we need to know that starch is made up of amylose and also amylopectin, which is about 25% of amylose and 75% of amylopectin. So starch thickens the instant custard by the process called as gelatinization, where the starch will break down the intermolecular bonds of starch molecules with the presence of water, which acts as the solvent, and heat. Also, it allows the hydrogen bonding sites to absorb more molecules of water. Then, it results in granular swelling, crystallite melting, viscosity increment, solubilization, and to form inner gel. Okay, so the starch that we use in our instant custard is the cornstarch. Okay, so there are few things that we need to know whenever we want to heat our instant custard that contains the cornstarch. First is the swelling temperature and the gelatinization temperature. Okay, the swelling temperature for cornstarch is about 60 degrees Celsius. Okay, which is that the granules will swell about 30 times from the original size, and for gelatinization temperature of cornstarch is about 62 until 72 degrees Celsius, which means that the excessive heating for the instant custard that contains of cornstarch may cause evaporation of the water and shrinkage of the gel. And according to a study, Crawford et al. 2015 determined that at least 52.5% cornstarch is required to produce a strong and sufficient of thickening behavior. You may refer to the graph below.
So the microwavability of starch is determined by the dielectric properties, which are the dielectric constant, the dielectric loss factor, and the penetration depth, which these affect the food's ability to absorb electromagnetic radiation, and then how easily they can dissipate this radiation into heat, and also how deeply the radiation can penetrate into the food before the intensity falls to ineffective levels. So in order to produce a food that is suitable for microwave cooking, all these three variables have to be high enough so that the starch can be heated to gelatinization temperature very quickly in a microwave oven. Dielectric constant and the loss factors of the food item can first be determined with the Debye models, which are using the following formulas, which is written right here, and they can also be determined with a dielectric probe and a network analyzer in an experimental procedure, as is done by these researchers in the United 38. And from that same paper, we have determined that the dielectric values of cornstarch at 30 degrees Celsius with 1 to 2 starch-water ratio is about 53.4 at the dielectric constant, 9.4 for the dielectric loss factor, and around 1.75 for penetration depth. So these values will be shown in diagrams that will be displayed later. So now with base values, we can talk about the factors that can affect the dielectric properties of a food. So the first is temperature. And it is said that dielectric properties of starch suspensions will decrease with the temperature increase in the presence of free water, because starch suspensions are full of free water. So this means that if you look at figure 3, you will want your starch to have low gelatinization temperatures so that the custard can cook quickly before the temperature of the mixture goes too high and reduces the effectiveness of the microwave heating. Moving on to moisture content, first you have to know that instant custard, when with this mix of water, which is about 400 grams of powder to 1 liter of water, it will give you a moisture content of about 60%. So this means that an instant custard mixture has a lot of water in it, mostly free water and some bound water, because the starch molecules will bind to some water. And since dielectric properties are known to increase with moisture content, the concentration of free water in the custard suspension is usually enough to counteract the decrease in dielectric properties that is caused by high temperatures. So you can observe this phenomenon in tables 1, 2, and table 3 that will be coming afterwards, where you can see that the samples with higher water ratios tend to have higher dielectric values, be it the constant or the loss factor. Now, another thing to note is that instant custard, it does form a suspension when it is mixed with water, so it means that a lot of free water is present in the mixture before and after cooking. So this means that it is full of liquid water, and liquid water is very polar, so it can easily absorb microwave energy via dipolar rotation. So therefore we can say that when heating instant custard, the main heating mechanism used here is dipolar rotation. So with those two factors in mind, we can say that cornstarch is suitable for making a microwavable instant custard powder, as its penetration depth, as you can see in this figure here, will remain stable even as temperatures rise. So this means that cornstarch will be able to continue to convert a stable amount of electromagnetic waves to heat, even as its dielectric factors shift a little bit with the temperature changes. Last but not least, we can talk about the effect of compositions and concentration on the dielectric properties of the overall system. So we can see that the concentration of starch in the system can actually reduce the amount of free water in the system, because more water will be bound to the starch molecules, and this will lead to less dipolar rotations in the system, and it will reduce both the dielectric constant and the loss factor. And then next up will be the presence of additives such as sugars and oils, because, for example, oils are known to introduce regions of hydrophobic lipids in the suspension, and this will dilute the presence of free water throughout the system, and it will also reduce the dielectric properties and reduce the microwave effect on the system.
The pros and cons of heating method between microwave versus stove. Although a microwave does not save much energy or money when boiling or heating water compared to a stove burner, it can be substantially more energy efficient when cooking food than a standard full-size oven. For microwave, use the right size pan for the work. Make sure to use the right size pan for the work, as smaller pans are less expensive and energy efficient to heat. A microwave is far more efficient than a stovetop for heating, mainly because a stovetop wastes a lot of heat. For our mini project, we choose cornstarch versus tapioca starch, and this is the differential between cornstarch versus tapioca starch, including the source, salt appearance, and temperature tolerance.
Despite the delicious taste of the instant custard itself, this custard can benefit consumers generally and also in the culinary field. Here are some reasons to support the production of instant custard powder, which are generally cost, availability, shelf life, storage efficiency, and for the culinary field, texture, convenience, stability, and diverse application. Shelf life. Instant custard powder is produced by reducing water content to lower the rate of quality degradation and prevent it from broken down in its natural biological environment. Thus, the microbial growth can be prevented as the water activity is at a very low rate, which prolongs the shelf life of the food product itself. Storage efficiency. When water is removed, the bulk weight and the volume filled by the food also reduce. Hence, it requires little space to store the instant custard powder itself. The ability of powder to be compressed without damaging the food and the flow rate sensitivity that is dependent on the rate of shear rate applied provide control when storing the food. Cost. The cost of production is also lower as the process is done in bulk. The process for transportation can also be safe as it doesn't need any special requirements such as cooling system. Also, type of transportation can be varied because the food has longer shelf life. As for the availability, the instant custard powder is convenient to find and the ingredient used is also easy to access. Texture. The custard has creamy and velvety texture throughout. The texture is same as normal cooked custard, which is non-Newtonian liquid that can change when force is applied to either more liquid or more solid. The consistency can vary by the amount of water added. As for the convenience, the delicious custard can be obtained only by adding water to the instant custard powder. The preparation process only requires a few minutes in the microwave before being consumed. Normally, when making custard traditionally, the amount is based on the ingredient used and cause wastage. While when using the instant custard powder, the amount can be controlled and the excess can be stored for a long time. Stability. The custard has same texture and taste with fixed amount of water. Food poisoning can also be avoided as the ingredient will undergo numerous cooking process and pasteurization before provided to the consumer. For the diverse application, although the original flavor is suitable with most food, the custard powder can also be integrated easily with other flavor as it is in powder form. Hence, various tastes can be obtained.
As a conclusion, we have discussed the effect of microwave heating to the cornstarch. Microwave radiation on the food depends on the dielectric properties of the food product, which are the microwave response characteristics of the food and the penetration depth. Cornstarch is the main ingredient in the instant custard powder, since it is excellent for thickening liquid and dissolve rapidly. Cornstarch is a very versatile starch. It is a white powdery substance made from the cornstarchy endosperm that is flavorless. Cornstarch adds a crumbly dessert-like texture to cake, cookie and shortbread recipe. The use of cornstarch in the instant custard is: first, cornstarch is often used as a thickening agent. Because cornstarch is denser than the flour, it requires less cornstarch to thicken a liquid to the desired consistency. When cornstarch is added to the recipe, it works by absorbing water and thickening the mixture. When the molecules are heated, they expand and consume even more of the liquid in the mixture. After complete heating, the starch in the mixture will have increased in size by 6 to 10 times its size. Second, the cornstarch is useful as an anti-caking agent. The cornstarch will assist in prevent lumps in finely ground foods like sugar by keeping its moisture and condensation from reaching the mixture. Lastly, microwave radiation is an important physical method to change the structure and properties of starch, and it involves a complex mechanism of action between microwave radiation and the food, and the moisture content of the food. Microwave can cause rearrangement of molecular structure and change starch water absorption, solubility, and swelling properties. For the second question, we could improve the skill in measurement method for determining engineering properties of food by use more advanced technology such computational engineering. In the early days, physical property analysis of food product required constant uniform value for each type of food. However, they were often too simple or inaccurate. Nowadays, computational engineering techniques such finite element method are much more advanced and can be used to look at non-uniform characteristics like thermal properties that change with time and temperature, as well as where they are in food products that are heated or cooled. Improvement in measuring food composition are now allowing more precise prediction because engineering qualities may be estimated using current numerical and empirical models of food composition, temperature, and porosity. A numerous mathematical function has previously been fitted to experimental data in order to clarify which component or interaction are significant in a food system.
Next, participating in university research projects as an assistant. Students can apply for as research assistant in university research projects during their semester breaks under the Food Engineering Department or the Food Science Faculty. By joining a research project, a student can be exposed to first-hand experience in how food-related research is conducted, including how the engineering properties of food products and agricultural goods are determined. For example, by participating in a research project focused on preserving the freshness of produce such as cucumbers, pressure tests will be conducted to determine the turgidity of the cucumbers, etc. In addition, read journals or articles that related to any engineering properties and take note how they handle for the measurement. First, focus on the information in the article that is relevant to your research question. You may be able to skim over other parts. Close read by deciding what parts of the reading are worthy of deeper study. This requires investigating early perceptions and scrutinizing possible significances. Authors of journal articles always have an argument. They are trying to convince you of something. Good authors present you with new research-based information.
By conducting indirect research, which include critical thinking, knowledge and values, can help to improve and increase the knowledge on the measurement method or techniques for determining engineering properties of food and agricultural product. As we all know that engineering properties cover a wide range of properties which are thermal properties, optical properties, electrical properties, structural properties, geometrical properties, mechanical properties and many more. Hence, method for determining engineering properties of food is very wide. So, research should be done by running a survey to study various people's point of view on type of food. The survey should be done in a focus group. This will help to identify the preference of each individual deeper. For example, by using their gender, age, country, and other. Indirect research helps in providing clues about what could be assessed directly and can flesh out areas that direct assessment does not cover.